I think we're good to go ahead and get started now. Okay, so again, coverage of this problem was in all four of my premium materials is what I'll call it. So Grokking literally covered this, Alex Shu covered it, Stanley Shiang, this book covered it, so did Lewis-Lin. This guy actually had 2 different chapters on it. We are going to be covering sending and receiving messages. We're going to cover joining groups. I can mark down out of scope. Going to be the presence indicator. I just don't want to cover that today. And again, cover all 3 of these approaches, 3 for CDC, 2 variations. I didn't really get around to the numbers. I really wish I did. All right, I can go ahead and start walking through the different approaches for the message receipts. So we will have the browser for the sender. And we'll have the browser for receiving messages. And we'll also have a browser for connecting. That is important to kind of cover separately. Machine connection. Because that's you're going to need to store the actual connection thing. I can kind of show that when we get into it with when we start to look at the CDC a little bit more. So you have this, you're going to have the backend service. It's going to be we'll just call it the messaging service. You can actually break part of it to not be stateful, I believe. We'll get into that in a second. We can probably talk about the short polling approach first, which is the most intuitive for people that are not super familiar with how to tackle this problem. Let's go ahead and draw a dashed box to indicate that this is horizontally scaled, just like that. So you send in a message like that. And let's say that you are doing like polling over here, like every minute your browser will send a request to pull in some messages. So we'll do that. Let's make it curved. And so you send a message and then it would get stored over in this message database. So you send in the request, it writes it to the database. Database says 200 okay, I've received it, and then it returns a success to the sender. With polling, it's just every single time every minute you go, hey, any messages, and then it does a read off of the message DB. So this is the polling approach. It's like that. There's no, it's stateless. So we'll go ahead and label it as a stateless. And we're going to say that this is the short polling approach. Okay, so no establishing a connection thing at all in this case. I can go ahead and draw an X like that. Let's go ahead and look at, I'm actually going to do the WebSocket approach before the long polling one. And then when I'll dig into this further, and then you'll understand why the long polling approach just is, it doesn't really make sense in any cases. I think short polling does actually make sense in a couple of use cases, but for long polling, I think it's a lot harder to find a use case for it. So let's go ahead and copy this, and then we're going to go ahead and draw the diagram for the stateful, the WebSocket approach. So I'm going to give us a little bit more space because this is going to be a lot more epic of a diagram. You can actually kind of delete this. We're going to ignore it for a second. So this will be stateful. This will be the WebSocket approach. So you got the sender. You're going to open up a persistent connection with the messaging service. That is something, it makes this a lot different than the other one, is that we're going to keep this persistent connection to a specific machine open. And when you send a message, it should actually go ahead and forward it over to the appropriate machine. And then this is where a lot of hand waving kind of goes on in some of the use cases that I've looked at. This could be something like Redis pub sub, for example. So you got this, and then it forwards it over, and I'm gonna say this is the WebSocket connection. Do that, make it smaller. We're going to say that the text is going to be small, just like a little thing. It's maintained on all of our stuff. And then you're not doing a pull over here, you're doing a push of a message, as opposed to this where you're pulling it in. So this is also called the pull-based approach, while this one is the push-based approach. Now, I said that this is doing a lot of hand waving, so we can go ahead and dive a little bit further into it. So I'm going to copy this, and I'll show you where the hand waving is going on here. This is roughly what I saw in Alex Shu's book. Some of the other ones also did this, but it's a lot of hand waving. So how does it know what machine to forward the request to? How does this thing know? How does the Redis pub sub know what machine it's going to send the message into? It doesn't. That's the problem. There's a question in the chat. It is, what does stateless mean? Means that the server maintains state. So as opposed to, usually state goes in the database. But like state is like information that goes across requests. It's information that spans between request and response things. So usually all services are stateless. Usually all the state stays in the database, and there's no information that spans across your request. It all has to be retrieved at runtime. But when it's stateful, there's a connection that stays there, and it knows who to bring it back to, or like allegedly there's hand waving here. So usually when you're doing horizontally scaling, it all remains stateless. But with WebSockets, they're very special because it's actually stateful. Okay, so like I said, though, this is doing some hand waving because it's like, how does it know what machine to connect to? And well, so that means that there should actually be some kind of data store that should maintain a mapping of user to machine mapping. And so with Redis pub sub, it's a push-based thing. I think you should go ahead and do something that's pull-based. Then you're going to need task runners. There's probably an approach to keep it with Redis pub sub, but there's other trade-offs involved in that as well. So with Redis pub sub and like RabbitMQ and a lot of other brokers, you can get back pressure, and then when there's when one of the downstream things goes down, you have the risk of getting back pressure. While with streams, you don't really have that risk. So we got these task runners. You know what user that you want to, well, so you'd also have a fan out. You have to do an upstream fan out. So we're going to need a fan out up here. And then we're going to also need to do a map user ID to machine ID. And that's what this task runner is going to do. We're going to have messages in here in Kafka that, let's have the schema for our messages. It's going to have user ID, And then that's the receiving user. And you got the message. Say some stuff like that. It's got the user ID, but you don't know what machine that their connection is being persisted on. And so that's where this comes into play, is that we have this mapping that's stored of what machine you're going to have to send it to. So now it knows what machine you're going to send it to, and it forwards it to the actual machine. Boom. And then it can send it over there. So that was part of the hand waving. And then you're also going to need to store a mapping on the messaging service from user ID to the socket. So each service can have something like 65,000 open connections each. So if I did the numbers for this, that would be one of the interesting numbers that I could calculate, is how many machines that we need in order to support a certain number of concurrent open sockets. But you're also going to need to map the user ID to the machine, to this connection object. That is local to each machine. So that's like, you're going to use something like Redis or something, and it's actually going to be a machine specific thing. Let's draw an arrow to point to what I'm talking about. There we go. All right, so you're going to have machine specific stores of the user ID to the connection. So that's why I'm going to have to loop back to establishing a connection. You didn't have to do this in the case of short polling because it's stateless, but now it's stateful. Stateful, we got state right there stored on the machine. And now that's why it's different than short polling. That's why this is very different than our usual horizontal scaling approach. Okay, let's talk about establishing a connection. I didn't have to handle that over in the short polling approach. We do need it over here though. So we actually have to deal with the establishing a connection thing. So we have the messaging service. I'm going to paste that over here. So you are hitting up the messaging service, and there should actually be some kind of load balancer or something that talks to service discovery. I'm hand waving that right now. I'm hand waving that right now, but there should be something that picks a specific machine for you to open your connection to. And then you would have that stateful WebSocket connection set up to that WebSocket. And it's also written over here to the user mapping store. So you're going to do a write operation over to this from the messaging service after so that would, we can loop back to that later. This is no other resources that I talked about earlier really even cover this at all. Like it's kind of like touched in Alex Shu's book for the establishing part, but then it doesn't talk about like doing this server ID mapping, while Stanley's book handles it. Grokking kind of handles this part. Grokking handled this. It didn't handle this. Stanley's handled this. Lewis Lenz might have also touched this, but not the socket part, which Grokking miraculously actually covered. So I've already covered a lot more than those other materials have, and I'd like to cover it's like the service discovery part. I'd like to dig into that later, but after talking about why long polling doesn't really make a lot of sense. Okay, so we got our establishing connection. It hooks you up to a specific server. Let's drag this over. This is just showing like, hey, horizontally scaled stateful connections. We've got this. It's written when you're establishing a connection over here. Now I think we're finally ready to talk about the long polling approach. So long polling, I think, doesn't really have a place very often because you actually have to hold this. With long polling, if you were just going to do a key range query like this one, where you're just doing, where you just hold it on the service for like a couple seconds, and then you do a key range query, and then you return a response. Why don't you just do short polling instead of like holding that connection open for a while on the server? because then that would also like free up the connections on the server more, and you're not bound by these like this like time bound thing on your requests. So I think similarly on a long polling approach, you would actually kind of be batching up these things from the pub sub thing. You actually have to store your request object or some kind of connection object on the long polling approach as well. So in the long polling approach, you're actually similarly going to have something that looks as complicated as this WebSocket approach. So in establishing connection, you're just going to be attaching, let's actually say, okay, we're going to say long polling approach before polling approach. So here you're going to be writing your request object. It's your connection object still has to get stored statefully. So with long polling, you still have to do stateful stuff, is what I was trying to get at. You still have a stateful thing. You still have a connection object of the request. And so like you still have all this additional complexity, but you have to keep opening up a connection every so often. So I think it has the advantage that it might allow for better rebalancing. I think the rebalancing stuff is kind of handled for you on long polling, but you still have all the complexity of doing stateful connection objects. Okay, instead of trying to draw that out further or describe it better on this diagram, I think I'm just going to capture the pro and con over here, and then we can move on to the CDC approaches, which I think are also a really interesting thing that I haven't seen covered in any other materials. So I want to wrap this up on this approach. It's you still there we go. Okay, let's go ahead and move on to the change data capture approaches. All right, I'm going to use the WebSocket approach going forward because that's what most people do with the chat applications. They're usually going to have something that looks a lot more like this than doing the short polling approach. It does have its place. Short polling, I think, does have its place for large group applications like Slack, but WebSockets are still, I think, going to be used in those approaches. So we're going to use the DB trigger approach first for change data capture. We're going to cover the DB trigger approach first. This will be the easiest to draw. That we still need the fan out. I didn't talk about joining groups at all. We'll go ahead and hand wave that for now, and I'll get back to that after covering these three different CDC approaches. So we're going to need the message data store. So when you're freshly joining a group, you're loading up like Discord or something, it's going to do a key range query and pull that all in, while for live messaging, it's going to use this. Yeah, so we need to have this thing, and you're first going to write it to the message data store, and then it'll hit, and then you're going to do a DB trigger, and you'll have it fan out. I really need a lot more space here. I definitely need more space here. Yeah. Okay, we'll just drag that back up when I have this piece figured out. So we have the message data store. Then you're going to do your DB trigger, and it's going to have to do the fan out. Let's label that as CDC with DB trigger. And we're going to fan it out here as well. Okay, yeah, I did kind of gloss over that. I'm going to draw this, and then we can loop back to this question again. Thanks for bearing with me. Okay, message data store. So we also have this group user data store. For specifically what, so with Telegram, you definitely need this. WhatsApp is encrypted. And so this is actually done slightly differently for WhatsApp. And I can even talk about that as well at the end. I'll make a note to actually does the user list fetch on client side. Huge thanks to somebody in the Discord chat from earlier today on tell me about this. So first so you have the receiving one, you know what group it is for, and then you're going to fetch all the users that you need to fan out to. And then you're going to do a crap load of writes over to Kafka. So this is similarly to, this is a little bit similar to Twitter's fan out. You have the group ID. Okay. This is slightly more legible. So you have the group ID, and then you receive a list of the users in the group, and then you're going to send a message to each one. Kafka is going to receive that message for each of the user IDs, and then the task runner is going to pull that off. That's actually a little bit more accurate of a way to illustrate that is that with Kafka, you actually do a pull off of Kafka, and you'll have the user ID. You're going to map that to a machine. You send that to the proper machine, and then that machine is going to internally map it to the proper socket for the user ID of that message. Boom, sent, you receive the message. There you go. That's how that whole thing is going to work without any hand waving. Okay, now I will go back to long polling. So long polling. Yeah, so you still have to maintain a connection object for the request. With short polling, you're just going to do a key range query over here. You don't need to do anything stateful. It's stateless over here with short polling. While long polling, you don't have a WebSocket connection, but it's a connection object. So when you're doing your poll, yeah, so you don't like establish a connection really. It would be that. So you have your thing comes in, and then that is stored here, user ID to the request object. I think you would maybe also want to do a write operation to this in order for the task runner that's fanning out the messages to know where to fan it out to. So you've got that, you've opened up your connection object. So opening up the connection object, and you store the user ID to the request object over here. And then while it's open, you've got these messages being sent. You do the fan out. The task runners have to do still a lookup of, hey, what machine is it on? And so it still needs to know what machine to map it to. And so then it's going to figure that out. And then it'll stick it over here on your request object. It'll pair it to that. And then when the service decides, I think it will have to use actors, like the actor model, like from Akka. I don't know if you're familiar with that. So Akka, actor concurrency pattern. It's probably how you would organize that. And then when the actor has been like, all right, we've held it open for 3 seconds, time to close off the request and send it back, I guess it would then do another write to kill this. And then it would return the request back. But you're still maintaining this like socket connection. It's like a opened request, and you got this request object thing. It just like hangs on the server, batching up a bunch of writes, but like there's just like this mess of concurrency with trying to hold it open still. So like long polling is like WebSockets, but with way more complexity. And it like the only thing you manage to avoid is the rebalancing logic is like, how do you rebalance a bunch of WebSockets when you decide to kill one of the messaging services? But like, it doesn't simplify this whole fan out thing. It's literally way more straightforward to just do the key range queries with short polling instead. It like doesn't save you a lot of complexity. Does that kind of make sense? That's my best explanation for it, is that it's WebSockets still basically just like not held for hours or minutes on end. It's like really short-lived WebSockets. It's the long polling approach is kind of like WebSockets light. But like, you're still setting up this whole socket thing. So like, why would you go through the trouble of doing WebSockets light? It's not really going to save you a lot of complexity here. That might have still been a poor explanation. I'm sorry. That's how I think about it, the WebSockets light. Let's maybe try to move back onto, okay. Cool, thanks. Awesome. I'm happy that was a good explanation. Okay. Also coming from to the fan out part, should we not use caching for the fan out? Like of the group user data store? I mean, I would use something like I would use I wouldn't use Cassandra there. I would use something like DynamoDB for this, which is good for, it's B-tree based, so the reads are kind of fast, and you can do read replicas. So this is probably going to be read heavy. Yeah, this will probably be read heavy. So you'd probably want to use DynamoDB, or possibly even, you could even do Redis as like, you could do Redis read replicas. That's totally a thing. You can do heterogeneous DB instance setup. That's totally a thing you can do. It's not done a whole lot, so it's like weird. I'm going to go ahead and add in the use case for joining a group. And this is stateless, actually. You don't need to do sockets for joining group. It can just go through the HTTP service. In fact, the sending part actually can also be made stateless, I feel, because you're not like, you only need the WebSockets for server side events, like a push instead of a pull in. And like this one, you're pushing to the server. It's client side triggered, so you can actually make that one stateless as well. So let's do that. You don't need the WebSocket necessarily there. It could be done. It's not, I think, completely 100% necessary. I'm pretty sure you can get away with it on this is the send service now. And then you also have the other one becomes the receive service. So this one is stateless. This one is stateless. And then this one is stateful. I probably just threw a whole bunch of extra information that might have just totally blown your mind. I apologize. You can forget about that, and just maybe know that the group join service, we're going to call it the group join service. God, I'm so awful at naming things. I'm sorry. So you're trying to join a specific group, and then that is where the write operation is going to occur for this. And so you're going to do a write over to this. And then it's going to say 200 OK, you've joined the group. 200 OK, hey, you've joined the group. And that is stateless. You don't have to do any kind of stateful stuff there. And so this one, I'm thinking you can do DynamoDB. It's going to be read heavy. So DynamoDB over here. and then you can even do like DB triggers or something, and you can like do Redis even over here. So it's optionally using a heterogeneous DB. I think DynamoDB is probably fine. I mean, I've never actually worked on a meshing app, but I'm thinking that it would be within data center, and so it's maybe not going to be too heavy. If you really care about latency, that's a good call out. If it's really heavy latency, then yeah. Okay, I see some more stuff in the chat. Okay, we've got this quick note for Kafka on CDC. You likely want to optimize for throughput, which will come at the expense of. Right. Okay. So that's another place where latency. So Redis would help with latency, and then if you switch over to Redis pub sub, that would also help crank down the latency, because Kafka does reads at 5 times per second. It's going to have a delay of at least 200 milliseconds if you're going to use Kafka. So I think that was even something that I wanted to talk about at some point is push-based versus pull-based brokers. So which is Kafka versus pull-based. No, that one's pull-based is Kafka versus push-based, which is Redis pub sub. And somebody had called out that what was the name of it? RabbitMQ is also push-based. Apparently. Well, that's what he said. I haven't double checked that. I'm very confident that this one's push-based though. So if you do Redis pub sub though, that would be a lot quicker. You could even do, I guess you could do the user machine mapping before this, and then the pub sub thing could even go straight to the proper machine ID. And that would also be a lot, that might even be a cleaner way to do things. Great call out though, that Kafka is going to be at least 200 milliseconds of latency. And I see a lot of stuff in the chat. Maybe I said some really controversial stuff. I like to paste these things in the text file just so that people that view this asynchronously will be able to view it, but also then I don't expose your names on the text file and on YouTube if you're not okay with that. Okay, but joining your group would be a write-heavy operate. Well, so when you would join a group, but then also you have to read it. So it's how often are you going to be joining a group versus sending a message? And every time you send a message, it might check, hey, what group is this person? You know, what group is, who all is in this group for this message that I'm fanning out? So I think that it's going to be checking what users to fan it out to a lot more than you're going to be joining groups. It's a matter of reading. It's a matter of how often you receive a new message versus how often you join a group, and you receive new messages more often than you join groups. That would make it read heavy. Let me know if I interpreted that wrong, for if I was thinking through that wrong. Feel free to correct me, but I'm fairly certain it would actually be read heavy. And we're great question though. Consider a famous person saying top 1K people joining the group would be given great discounted courses / coupons. I don't know. I don't know why that would make a difference, because then let's say that the 1,000 people would receive you're saying that a famous person joins a group and says that 1,000 people joining it will be given a great discount. are you saying like on Twitter they do that? And so then they tweet like, hey, join my group. The first 1,000 people receive some kind of discount or something. Well, so then that's a weird edge case that would result in a bunch of people joining a group, but that's rare relative to the average case on Discord. And so that would be trying to morph it into a different problem than what the average case is. Oh, I pasted that twice. Also for Kafka, would you consider multi-region consistency as people from different parts of the world can be in the same group? You might, so we will be having eventual consistency. We'll have eventual consistency. Okay, there's a lot of questions going on here. So it's eventually going to hit all the clients, and then it's maybe you're worried about the ordering of the concern might be over maintaining ordering of messages. So you could maybe have one message received before an earlier sent message occurs. So yes, I think that could look weird. But you can have the client properly sorted out on their end. And you can have the timestamps handled on the server side. And so that would probably, I think it'd be a lot better to use server side timestamps. That would help a little bit with maintaining the making the ordering not jump around as much. I think when you use the server's timestamps, because there should be less, there's less data center to data center round trips, even if it's from between Amsterdam and like San Francisco, they'll be much tighter than the round trips from like, let's say North Dakota to Seattle. Even though that's like within the US, if a client is located in North Dakota, like, and they're like on their browser, a client server request is almost always going to take way more time than a data center to data center trip, even if that data center things like, you know, United States to China and stuff like that. They just have way better internet connections, while your clients might have like dial-up or something like that. Okay. We're not going to cover that. We're not going to cover that. That is a completely different question. I got other problems on my channel that cover that. Yeah, you got to constrain your scope on these. Otherwise, it's good. I would literally take me 5 hours to handle. No, that's not where I need to put it. I need to cover that on this. It literally take me 5 hours to cover all the possible bells and whistles I could have on this problem if I handled that. That'd be a fun one though. That would be fun. Sorry. Every possible user having hundreds of chats or thousands of. Okay. Feel free to repost your comment if I somehow manage to skip over any. I do like to try and cover everyone's questions because it really helps me sharpen my content a lot. I think I did already see that one. Wow, someone has a really fancy diagram on here. Am I able to open that? I'm trying to open this diagram. Okay, is it in downloads? Whoa, that's a PDF. Somebody posted a whole PDF in the chat. Where the heck was that diagram though? Kafka optimization theorem. Sorry, I got this at least. I have no idea where that thing with 4 diagrams is in it, or the 4 arrows. All right, sorry. And then I've also see there was another message, but okay, whatever. I'll skip that other one. With every user having, oh, okay, it's I open this. There it is. Oh, geez. There we go. Okay, cool. I got that thing open now. Kafka optimization theorem. I have never seen this before. Okay, so you have a trade-off between latency and throughput, really. And then availability. This one makes sense. The availability durability trade-off is that you would naturally need to have more replicas that have it persisted, which decreases the risk of durability, while availability is like you only need the fastest replica to give you a thumbs up. I haven't seen that trade-off before though. That one's interesting. Let's make sure I copy this into the text file for Discord group later. There we go. I attach this over here. Yes, nice. Okay. Cool. Yeah. And this will be posted in the Discord chat later for the people in the Zoom meeting. With every user possible having hundreds of chats and thousands of messages, WhatsApp keeps the backup on user device so it doesn't have or doesn't store or have the state. With every user possible having hundreds of chats or thousands, WhatsApp keeps the backup on user device so it doesn't store or have the state. WhatsApp doesn't. WhatsApp persists things, I think, on the device more so than the site. Although, how does big message service? Do they save messages? So other ones do. So that's I do have a message data store over here in the design. For Kafka, how would you consider multi-region? I think I did cover that one. Yes, I did. Okay. Actually, tune Kafka to your SLO if you don't want to swap to Redis pub sub. Nice. Okay, I get why you posted that. Cool. Thank you. Yeah. Well, so now I've captured it, so everyone will be able to see it in the Discord group. Let's keep going. Yeah. Okay. So I've got here my DB trigger approach. And I wanted to show the other approaches for change data capture. Let's make that extra large. And then we're going to show the 2 other approaches for change data capture that I was thinking of. We're going to cover the approach for, where was it? DB subscribe to the broker. And then there's also the 2 calls from the send server approach. This is the DB trigger approach, and then we're going to do the DB subscriber approach, and then we got the 2 calls approach. So DB subscriber approach, we're going to take this, and we're actually going to have it over on the end of the message queues, how we could do it. You would probably want to have your fan out like, okay, can you do... You'd probably have your fan out after the broker. And then, okay, yeah, you have it at each user ID. Anyways, you just stick it straight onto the, you can even have the broker of, it could be group ID and the user ID, and then you could somehow have the fan out at the end, I think. That would make the most sense here. That would make the most sense. You would have this moved. Going to delete this. Going to delete this. We're going to move this up to here. And then we're going to have the DB as one of the subscribers, like that. And then we're also going to have the fan out, which is going to go, I think we need more space. So we also have the fan out over here, which is going to look like it's going to pull a message off of Kafka. I'm still using Kafka instead of Redis pub sub. So you pull it off of Kafka, and then you have this for determining the user groups, the user list, and then you could have something else. You can use a service instead. It'd be the mapping service, or you could just use this directly from this the task runner. This could actually just do, yeah, you could just skip having two different things, and then you would just have this thing doing both. Just like that. Then you have your messaging service right there. Okay. Trying to make this look a little bit less horrible. And there you go. We have the message data store subscribing to Kafka. And then when you're going into a new channel, which I've hand waved a little bit, you would do a key range query off the message data store. So I could kind of do that. It's on your first load of the messages, you're not actually going to need the socket quite as much. So that would be loading messages, full messages of a channel. So that's like when you first like switch to a different channel or something in Discord or in Slack, you would send a request to it's like historical. Stanley Chang had a really good name for this. I think it was like historical messages. That was how he explained it. So you do a request to the historical messages service when you're switching a group, and then you're going to do a key range query over here. And then it'll send a 200 request over here. So I'll do data flow arrows like that. And it is a key range query. But this is actually going to be write heavy because you actually only do this whenever you switch channels, but you should be writing to channel more often than switching channels or doing a full load of a channel. So it actually makes sense to use Cassandra over here. Yeah. Okay. This is over there. And there you have it. This is the DB subscriber approach. We also wanted the two calls approach. Which is where this thing is going to make two calls instead. The first one is to the message data store, and then the second one is just going to be directly over to the broker. It'll look a little bit like this. And again, you can have the fan out either before or after the group. If you have it before, you might have a task runner instead. So let's maybe, okay, you know what? I'm just going to go ahead and copy paste the approach from here for the two calls approach, and then it might make a little bit more sense. got this. Come on, zoom in. Okay. Come on. You would have the broker, and then you also have this thing. And delete that. Let's move this one up like that. You're first going to make a call over to Kafka. And then you're going to call the message data store. It could actually be either order. I haven't thought about the trade-offs of the ordering there. And then you still got your key range query against the historical message service, just like that. And there you go. So you just make two calls directly from the send service. And then so that the issues with this is that you have interesting partial failure scenarios. Like what if you get it onto Kafka, but not the data store? So you're probably going to want to get onto the data store first and then to Kafka. And then you would, but then maybe you'd have a message that's dropped on the fan out to all the receivers. And then that would look weird. It might just be like a missing message for a while. So that's why the partial failure scenarios here are just really weird. And I'd prefer to do one of the other approaches, but if you're an entry-level engineer and this is like your first system design ever, you're probably not going to think of those other CDC approaches. You're probably actually going to think of like, you're probably going to first think of the two calls approach instead of trying to do one of the other ones, the other approaches. So I'd call this maybe a naive approach. I just want to make sure that was covered on there. Okay, what else do I want to cover here? Okay, I wanted to talk about the large group variation. So what if you have a huge group? What if it's not just, a cap of 50 or 500 or whatever, like it is with WhatsApp? So Discord has like thousands of users easily in a group. While WhatsApp is like 50 to 500, it's like totally easy to find a server that has thousands of people in it. And so that means that your fan out worker from for the WebSocket, this is going to be fanning out to a ton of people. And it's going to be a lot more, it's going to be tremendously more read heavy on the messages. And so I was thinking, it was like, you might even want to like do batched up write operations or pushed notifications. You might want to like batch those up somehow, but then it's like, why don't you just do polling instead? Like if you're doing a batched up send, like if you're batching it up like that, that's the whole point of doing the polling. And so that is where I think you would maybe want to do short polling. I'm saying short polling because long polling still has that huge complexity of maintaining a connection object. And so that's why I wouldn't advocate that. But this approach might actually make sense when you're doing large group variations like Slack or Discord. Because if you're going to batch up the messages anyways, why not just go ahead and do polling? Because the whole point of switching from polling over to WebSockets is that if you're doing polling a lot, there's some of your polls might actually return empty. So like if it's a group of 50 people and you're online for hours, you're not going to be talking nonstop over the chat service. There'll be maybe like hours on end of nothing getting sent. And if you're polling every single minute, well, then you're going to get a bunch of empty requests. And so you would have a lot less back and forth between the server if you just go ahead and do server-side events like that. But when it's a service when it's a group that has literally thousands of people, there's actually a chance that there would be nonstop messaging on that group, like 24/7, and then it would actually make sense to do polling. So that is what I have to say about the variations between small groups and large groups. Another thing is that you can also, there's variations between messages that you actually receive push notifications for, like for example, @here or like @usernames sends a direct notification to your device even when you're offline. And then you can also subscribe or unsubscribe to receive a notification for all messages in a given channel, which also varies stuff. It varies whether or not it's like supposed to push a notification out. I don't want to dig into that because we've already gone rather deep into this problem, but I did want to call that out. So this is kind of like my favorite approach for the problem. This is kind of like my answer key. This is what's going to go in the thumbnail most likely. this is something that I'm rather happy with. Are there any other questions before we try and wrap this up? All right, I can't think of anything else I actually want to cover, so I guess I can let you guys go. Thanks for joining. I will see you guys next time. Thanks.